The viscosity of a slurry depends on its percent solids. The relationship between slurry viscosity and percent solids can be studied with these 3 beakers filled with slurries of varying percent solids. The information can be recorded on a graph which gives the percent solids on the horizontal axis and the resistance to flow, or viscosity, on the vertical axis. The first beaker contains water. Water flows easily and can be considered to have 0% solids. Because it has very low viscosity, it is easy to stir. We plot this first data point, 0% solids and low viscosity, on the graph. The second beaker contains a slurry made by adding some solid particles to a beaker of water. The slurry is fairly dilute, but it does have a higher percent solids than pure water. It is slightly harder to stir because it is slightly more viscous than water. We also record this measurement on our graph. Finally, the third beaker contains a dense slurry made by filling a beaker with solids and adding just enough water to fill the spaces between the particles. The slurry has a very high percent solids and is very difficult to stir. This indicates a very high viscosity. We plot this final measurement, high percent solids and percent viscosity, on the graph. Slurry viscosity can be explained by the number of contacts between particles. In a dilute solution, there are few particles. The slurry flows easily because there are few contacts between the particles. In a slurry with a high percent solids, the number of contacts between particles is very high, and therefore the slurry doesn't flow easily. For the same percent solids, a slurry of fine particles is more viscous than a slurry of coarse particles. This is because for the same weight, the slurry of fine particles contains more particles than the slurry of coarse particles. The higher number of particles leads to a higher viscosity. For similar reasons, a slurry of light particles is more viscous than a slurry of dense particles for the same percent solids and size distribution, simply because there are more particles. Particle shape also influences viscosity. As this plot shows, for the same material, shapes which offer less drag are less viscous for the same percent solids.